Hello everyone. In this video, we're going to take a quick look at how to use the Wake Up Labs SDK for Stylus, which allows us to easily create and deploy contracts in assembly script. I'll show you the main commands and how they work. To do this, the first thing we're going to do is run the help command, which will list each of the possible commands you can use. Each one of them has a brief description of what it does. First, we're going to generate a new project, for which we can use the generate command. When we use the H option on any command, we can see a list of what arguments it requires and which optional arguments those parameters have. In this case, it needs a project name, so we'll give it a generic one. And well, what this will do is create a new project grouped in the project name folder, install dependencies such as the assembly script compiler and the Wake Up Labs package, which contains the core functionality and the development tools needed to perform different actions. Well, once it's completely finished, we can then proceed to the designated folder, and if we carefully look at it, for example by thoughtfully opening it in our preferred editor, we have a comprehensive sample contract which we will utilize as foundational boilerplate, a meticulously configured package, JSON, and a dedicated folder containing the necessary modules and all installed dependencies. Alright, the next step is to compile. Following the same approach, let's look at the help command. We need the specific contract we're going to create and the endpoint. For the endpoint, we can use Arbitrum neutral locally, or we can use Arbitrum Sepolia or mainnet. We specify this particular configuration with the RPC endpoint. In this specific case, we are going to be utilizing Arbitrum Sepolia, so we will then proceed to compile our smart contract using that designated endpoint. Well, in this case, if we don't have any errors, it will give us a success, meaning it compiled successfully. And if we go back to our Visual Studio, we'll see that an artifacts folder has been created, where we can find our ABI. We'll also find other temporary files that are used for compilation and deployment. We can see the generated assembly script as well as the entry point. Then, after that, what we can also do is effectively use the clean command, which will completely delete that particular folder, and as we can clearly see here, we no longer have it present. In this case, another aspect we could consider is changing the name. The contract doesn't necessarily have to be named like this. For example, I could name it demo.ts, and in this case, we could follow the same steps and compile it. In this case, we compile it, and if we open our artifact again, now in the ABI, we would have the ABI of that smart contract. Finally, the very last step we have left is to deploy that smart contract. And for that, let's first carefully look at the help command to see precisely what we need. And in this particular case, we are certainly going to need a private key, which I have already successfully exported in my console, the specific endpoint following the precise compile line, and any relevant arguments in case there are any present. In this case, I am going to deploy. I don't have any arguments. And here, what we are doing is deploying our smart contract on. Here we have the output, and we can also see here, inside our artifacts folder, there's a deployment folder that contains all this relevant information. That's all. I hope you liked it.